Hi and welcome to this tutorial on using Kubernetes to build a local development environment and a local cluster. There's some benefits for doing this locally, and these include that it's good for testing, so we can test things out without fear of it affecting production or other environments. It's an isolated environment, so again we have that capacity to play around and experiment with Kubernetes. And also it's scalable, so if we do something locally, we are able to then do it in a more controlled environment when we're happy with it. So some of the tools that we will be working with are Minikube and Docker, and of course Kubernetes and kubectl as well, which is very useful for interacting with Kubernetes. So we will go through installing Kubernetes through Docker Desktop, which in my opinion is the most simplest way to do it. So we'll do that in the next video. We're now going to go through installing Docker Desktop. It will vary slightly depending on your make and model of device. I'm using a Mac, so I chose the Apple chip. Follow the instructions, and to verify that Docker's been installed, open a terminal and type in Docker. If it's been installed correctly, you will see all these options available to you. So the next thing we want to do is start the engine. So if we go into Launchpad and start typing in Docker Desktop and to run the program, you'll then be presented with the Docker Desktop client. In order to enable Kubernetes, you go onto Settings here, seen in the right hand corner, and you want to select Kubernetes here, and you want to make sure that these options are selected. And to verify that it's running, you can do it in different ways. One of the ways is to look down here and know that both Docker and Kubernetes are running. If we go up here, we can see more options, and we can see the same thing, and we can see that Docker again and Kubernetes is running. So the next step is to install Minikube, which will enable us to start the Kubernetes cluster locally, and also we need to install kubectl. So I'm going to go through those steps now. So to install Minikube, we go to the terminal, and if you're on a Mac, type in brew install cask Minikube. This should only take a few minutes, and we can see that it's installing various components. After this is done, we'll run a few Minikube commands to start the cluster, which will be running locally on our device. In another window, I can also install kubectl, which enables us to interact with the running cluster. And this is done by typing in brew install kubectl. So we can see it's already installed, so there's no need to reinstall it. So just to verify, I'll just type in kubectl. And we can see it's been installed as well, because we have all these commands showing that we can use to interact with the cluster. So in order to verify Minikube is installed, I'm going to type in Minikube version. And we can see it's been installed here. So the next step is to start a local cluster by using Minikube and to do basic interactions with it, which I will show in the next video. So the next step now is to start the Minikube cluster. So how we do that is we type in Minikube start. Just make sure that you've got Docker running and make sure that Kubernetes is running, because if it's not, this won't work. So after this has been created, we'll have a cluster running locally that we can interact with. Please note that it just takes a few minutes for it to get up and running. But once it's up and running, we can interact with the cluster. And note that it's in the default namespace. So now we can run kubectl commands like kubectl config current context, which will show we're currently in the Minikube context and interact with anything running on Minikube. So I'll just do kubectl get pods. And we can see, because we haven't actually set anything up yet, there's nothing available. And the same goes for kubectl get deployments. So the next step now is to actually start to deploy Kubernetes on this cluster. So we'll do that in the next video. Okay, so now we're going to interact with this cluster and we're going to run an application based upon it. So first of all, we need to create a deployment. So we do this by using the create deployment command. So I will just name it Hello Minikube project. And we are using this image. Now we can see it's been created. So just to verify, I'll do kubectl get deployments. And we can see Hello Minikube project is here. The next thing we have to do is expose the deployment. So I'm going to do that by typing in this command. And then this will create a service. So just to verify again, we can do kubectl get services. So we can see it's type node port and it's exposed here. And here shows you how long the service has been running. So if we do the command again, we'll see that this number will increase. So now it's been running for 26 seconds. So in order to access the service, we can do it in a few ways. For example, we can use the built-in command service, which will open the service in a new browser. We can do port forwarding, and we can also get the URL of the service and visit it that way. So that's the way that I will do it here. I've used the incorrect service name because we want to use Hello Minikube project. So we can see the services running on this address. So if I open a new browser and go there, we get all the service details here. So that's a basic introduction on how to run a service, run an application locally using Minikube. In the next video, we'll explain a little bit more about scaling and a bit about networking. So now I want to go through using MiniCube Dashboard, which is really useful in that it allows us to interact with our cluster using the UI as opposed to the command line. So first we need to check the status of Minikube and make sure that everything's running as expected by typing in Minikube status, and it is. So the next step is to start the dashboard by typing in Minikube Dashboard. This opens a new browser window with the details of our cluster, and we can interact with it visually. So note that everything in the Minikube cluster is created in the default namespace. So we can see our deployment here and our pods and our replica sets. We can see more details of other things on the left-hand side here. However, for this project, we will just keep it simple and go through the basics. So say I want to remove this deployment and completely delete it. I'm able to do this with using the UI. So as you can see here, I can scale it up by creating new replicas. So say I wanted to create 20 replicas. It's the same command that I can do on the command line by running this. However, some people do prefer to do it visually in the UI. So let's do that for now. So we can see now that we have 19 pods pending and 1 pod is still running. And now we're getting more pods that are running. So now everything's green and we've got 20 pods. So if something goes wrong with 1 pod, we can fall back on the others, which is really, really useful. Now, say I no longer want this deployment and I want to completely delete it and just get a fresh Minikube cluster. I'm able to go into the deployment pane here and select delete. And note again, it's the same as running kubectl delete the deployment in the default namespace. So I'm going to go ahead and delete it. Please note that it just might take a while to delete because obviously we have quite a lot of pods here. However, now we can see that there's nothing running in the default namespace and there's nothing available to be interacted with here. So that's a brief introduction to Minikube Dashboard and how we can remove deployments and increase capacity as well of the deployment. Okay, so now I'm going to talk a little bit about how we can manage pods and manage deployments. So generally a deployment is like a blueprint. So a lot of things like the creation of pods are abstracted when you create a deployment. So let's see what we've got at the moment. So we have our Minikube project as a deployment here. So what we're going to do is we're going to modify the image tag on the deployment, and that will update the pods automatically, and also it will update the replica sets. So we'll go through that. So for example, if I get a replica set now, we can see what we currently have. So we can see that this is the current replica set, which has been active for 4 minutes and 1 second. So what we're going to do now is we're going to edit the deployment, and we're going to do this by running this command here. Now we can edit the deployment file by looking for the image property. We can see the image here. So at the moment it's using this image and it's using the latest version of it, but we want to use a different version. So we'll go through that now. And please bear in mind, to edit this file, you just press the I. So as we can see, everything is up and running at the moment, and we can verify that it's using the latest image here. So I'm going to use the image that is specified in the Minikube docs, which is 1.0. So I'm going to modify the image here as 1.0 and save the file. So now that's been edited, we're going to get the pods again. And we can see that because we modified the image, there's a new pod that's been created, because we can see by the age it's only 8 seconds. And we can see that this image has been modified, because if we go on to get replica sets, we can see that our old replica set is no longer in use. So we can verify that the new image is being created by going back into the UI, Kubernetes Dashboard. And we can see that the deployment is now using the new image here. Notice that this has changed from latest to version 1.0. Notice that the deployment is still up and running from 34 minutes ago, so when we initially created it. However, the new pod, there's been a new pod that's been created. So basically, what to take from this section is we often interact with the deployment itself rather than having to modify the pods directly. So now I just want to talk to you a little bit about debugging, which is quite an important aspect of Kubernetes. And there's a few ways we can do this. So for example, for our current Minikube project, we can do something like kubectl logs and then the pod name. We can see that the logs are showing now, however there's not much here. So to show you a different example, I've made a deployment of a MongoDB instance. So if you run kubectl get deployments, we can see that MongoDB is up and running, which is one I created earlier. So if we get the pods again, I will get the name of the MongoDB pod here and type in kubectl logs and then the pod name. As you can see, there's a lot more logs here. We're not going to go into what these logs mean. However, it's useful if you are trying to debug a problem to be able to view the logs. So that's one way that you can do some debugging. Another way is by doing the describe command. So I will just get the name of the initial pod again, which is the Minikube one. We'll go back to the Minikube one. And if we do kubectl describe and then the pod name, sorry, we need to write kubectl describe pod and then the pod name. So this gives us a lot more information about what's going on with the pod. So we can see the name, the namespace, the node it's running on, and various other information as well. So we've gone through showing the logs, we've gone through using describe, and there's another thing we can do, which is to execute into the pod to view more information. So we'll do this with the MongoDB example I showed you earlier. So to do this, we do kubectl exec. We use the IT flag, which stands for interactive terminal, to enable us to go into the pod and actually interact with it. And then bin bash, and the pod name here. So this will enable us to actually interact with the pod itself. So as you can see, now we're root on the MongoDB pod. So we can run commands such as whoami, ls, and things like that. And we can actually view more information about the pod. So to exit this, you literally just type in exit. So that was a brief introduction on debugging Kubernetes locally using Minikube Cluster. So now I want to talk to you briefly about networking, and some things to bear in mind is that every pod gets its own IP address, and a NAT, network address translation, is not required. Pods can communicate without it to each other because they're typically in an isolated subnet and the IP addresses never overlap on a node. Something else to bear in mind is we can control the access by modifying the network policy. However, in this project, we're not going to go into that, but just bear in mind that by default, pods accept traffic from any source. So I've set up some Nginx pods to demonstrate the communication between pods. So to get the IP address, you need to set the O flag and set wide. So if I run that, we can see that there's different IP addresses here. Each one has a different IP address. So now we're going to execute a command within this pod and get a response from a different pod. So if I just run this, we can see that by running this, I've actually got a response from a different pod. So that sort of demonstrates how easy it is to communicate within a cluster and communicate between pods. So that's a brief introduction to networking because it can be very, very complex on Kubernetes. However, this is something to get you started. So now I just want to recap everything that we've learned in this project. So at the moment, we can see that we have still things running here. However, in order to completely clear the Minikube environment, which is good practice, we just need to run basically this simple command, which is minikube delete. So this will remove sort of all the resources that you have available at the moment. So to verify this, we can restart the dashboard and see that it's not working anymore. So I can also do this and it doesn't work because Minikube is not currently running. So just to recap, what we've learnt in this project is to set up a local development environment using Minikube. We've deployed a simple application. We've talked about the management of scaling containers, scaling deployments, brief networking concepts, and also debugging, which is very useful to know. Also talked about basic components such as pods, deployments, replica sets, and the like. So I would suggest for next steps is to deploy your own application and play around with the images available, which you can find on Docker Hub, and perhaps explore networking and security more if that's your area. Thank you. So in this section, I'm going to talk a little bit about networking in Kubernetes. So we're going to specifically focus on network policies, which is a Kubernetes resource which gives us more granularity over the rules. So some things to bear in mind is that pod communication in different namespaces are allowed by default. So if we want to control this a bit more, we should be using network policies. We can also use a service mesh, however that's not going to be discussed in this project. We need to install a plugin, the one that for the network policies to take effect. The one that we will install is called Calico, and we'll go through installing that. So in this section, we're going to do a few steps. So we're going to make sure that 3 namespaces are set up, namespace 1, 2, and 3. I will then get the pod IPs to demonstrate that every pod, regardless of namespace, has a unique identifier. To show that communication is allowed by default, we will ping from one pod in namespace 1 to another in namespace 2, and this should work successfully. The pods I will set up will be running Nginx, so we'll get the standard response. And then, so basically to demonstrate network policies, I will create an ingress policy to only allow traffic from namespace 1 to namespace 3. So if a pod in namespace 2 wants to ping a pod in namespace 3, this shouldn't be allowed. Because I haven't installed Calico, I should be able to still do this. So we'll install Calico then and then try it again. So that's a brief introduction about what will be covered in this networking section. So as mentioned, the next step that we're going to do is create 3 namespaces and create a deployment in each of these namespaces. So first of all, we will check how many namespaces we have at the moment. So we can see we have default, kube node lease, kube public and kube system. So I'm going to run kubectl create namespace, namespace 1, and then I will create another one and the last one. So now if we run this command again, we'll see that we have 3 namespaces available that we can use. So what I'm going to do now is create a deployment in each of these namespaces and demonstrate that a pod from namespace 1 is able to communicate with pods in other namespaces. So now what we're going to do is we're going to create a deployment in each of the namespaces. We'll create a deployment, an Nginx basic deployment based off this file. So how I'm going to do that is I'm going to run this command here, and I'm actually going to specify the namespace. So if we go back here, so we're applying this file, which is hosted online here, and I'm just going to add an additional tag to specify namespace 1, and then I will do the same for namespace 2 and namespace 3. So now if we run kubectl get pods, we can see that we have 2 pods specified. Let's check the pods in the specific namespace. So namespace 1 has 2 pods running, namespace 2 has 2 pods running, and namespace 3 has 2 pods running. So now let's check the IP addresses of these pods. So in order to do that, we do kubectl get pods, A for all, and we specify these flags to enable us to see the IP addresses. So we can see that all these IP addresses are different. Even if the pods are in the same namespace, the pod IPs are different and unique. So we can also run this command by specifying their namespace. However, I actually made a mistake there, because the first one, because I specified the all flag, I believe it disregards the namespace flag. So if you want to see a specific namespace, don't include the A flag. Yeah, and we can verify it's showing the pods in the different namespaces because the IPs are different. Okay, so now what I'm going to do is ping from a pod in one namespace to a pod in another namespace. So first I will get the IP of a pod in namespace 1, and then I will get the IP of a pod in namespace 2. So they are different here. And now I'm going to execute into the pod in namespace 1. So what we need to do is run kubectl execute the name of the pod, which is this one. Just remember, we have to specify the name of the pod, not the IP. And then you do 2 dashes, curl. And now I will choose a pod IP from namespace 2. So this one. Oh, I haven't. Remember that you also need to specify the namespace. So it's situated in namespace 1. So what we've done there is I've specified to execute into a pod, which is in namespace 1. Here, this one. And we've wanted to communicate with a pod in a different namespace, which is namespace 2. And we can see we get the Nginx response. So it's been successful. Now, what I want to do is I want to be able to set a network policy on namespace 2 to only allow communication from set a network policy on namespace 3 to only allow communication from namespace 1. So if namespace 2 tries to communicate with namespace 3, it won't be allowed because of the network policy that we set. So I want to talk about the policy that I'm using to achieve this blocking of anything coming from namespace 2. So we have to specify the kind as a network policy, and we want to deny any traffic coming from namespace 2 into namespace 3. The policy type will be ingress. Note, as I mentioned before, all traffic coming into pods default is allowed, so we want to have more granularity on this. So by setting up a network policy, so we are going to only allow traffic from namespaces that have this label permission allowed. So just to verify, if we check our namespaces, we can see that these ones are the ones that we're working with, namespace 1, 2 and 3. So earlier I created a label by running label kubectl label namespace 1, and then by running this. So now to verify the labels that we have, we can run kubectl describe namespace 1. So we can see it has the label that I literally just created and this permission allowed. So that's what allows it to be able to communicate with namespace 3. If we track namespace 2, it has permission denied. So that's just to demonstrate how you can communicate with pods via network, like by setting up a network policy based on namespace selectors. So now that the network policy has been set up, if I try to ping a pod in namespace 3 and I'm currently using a pod in namespace 2, it doesn't work. However, I will then ping a pod from namespace 1 to namespace 3, which should work. So we need to get the pod IPs and details by running kubectl get pods 0 wide in all namespaces, and by running this command here. So we will take a pod from namespace 1 and ping a pod in namespace 3. And as we can see, that worked. So that's a brief explanation, and just to confirm, I modified the network policy. So just to go through it again, we deny namespace 2. This is applied on namespace 3. The policy type will be ingress, so it affects traffic coming into namespace 3. And anything that has the label, and it will only allow anything that has the label allowed. So to recap, we've done quite a lot in this project. We've gone through Kubernetes and how to work with it locally using Minikube. Just to go through how to remove Minikube Cluster once you've finished working with it, and to clean up the environment, you do Minikube delete, which will remove the cluster and any remaining resources. So in order to verify that everything's been removed, you can run kubectl get pods, and you'll see this, just to confirm that everything's been removed. So we've worked with deployments, we've deployed an Nginx application, we've gone through scaling, we've also looked at networking concepts by using the Calico plugin to ping pods in different namespaces. We've also gone through key concepts of Kubernetes, such as pods, replica sets, scaling, things like that. If you'd like to explore Kubernetes further, I would suggest looking at the official documentation and just playing around with images, your own images or images on Docker Hub. I hope that project has been interesting for you.